All right, guys, so we're continuing on with matrices today. And most likely, as I was thinking about it more, the matrices will not be your semester final. It's just not going to take that long to go through all of them, I don't think. But we'll reevaluate that and look at that as we go through this chapter. So, matrices. Now, what we're going to look at today is three operations. Now, the first two are going to be addition and subtraction, and we've covered this once before. We can add two matrices or subtract two matrices from each other. And whenever we add or subtract, the matrices have to have the exact same dimensions. So if the dimensions are the exact same, then we can add or subtract them from each other. If they don't, then we cannot. So, and that's kind of what this here is explaining. If the dimensions are the same, we can add the corresponding elements or subtract the corresponding elements, depending on if we are adding or subtracting. And if you remember back to the last time we did this, it is possible to type these into the calculator, and I provided a link in Google Classroom to a video going over that. Now the first one we're going to look at is this here. So we're going to find each of the following. So find each of for the following kind of matrices. So we're going to do A plus B. So matrix A is going to be 16, 2, -9, and 8. And we're going to add to it matrix B, which is -4, -3, -1, and -7. So we're adding these two together. Now the first thing, again, like it said, for us to be able to add or subtract two matrices, they have to have the exact same dimensions. They have to have exactly the same dimensions. And matrix A is a 2 by 2, 2 rows and 2 columns. Matrix B is a 2 by 2, 2 rows, 2 columns. So we can add these together, and we would add corresponding elements. So we do 16 plus -4. And 16 plus -4 would be 12. And then we would do 2 plus -1, and 2 plus -1 would be 1. Then we would go down to the bottom and do -9 plus -3, which would give us -12. And I'm sorry about the numbers. I'm trying to use a mouse to write these, so it's a little bit difficult. So -12. And lastly, we would have 8 plus -7, and 8 plus -7 would be a +1. And that's it. This would be our matrix. Our new matrix, when adding these two together, would be 12, 1, -12, 1. And this would be it. That's all we'd have to do for this here. Now you could also go through and type these into the calculators for A and B, and then go A plus B, and that would do it also. And that's all we have to do for this one here. Now the next one we have is B minus C. Well, matrix B is going to be -4, -1, -3, -7. So that's matrix B. Minus matrix C is 8, 6. So we're having A minus, or B minus C. B minus C. And again, whenever we add or subtract two matrices, they have to have the exact same dimensions. And matrix B is a 2 by 2. And matrix C is a 2 by 1. Well, the matrices, the dimensions of these two matrices are not the exact same, so I cannot subtract them. Because the dimensions are the same, this is not possible. The only way that we would be able to add or subtract two matrices is if they have the exact same dimensions. Now, if you tried typing this into a calculator, it would say dimension error, because the dimensions for the two matrices are not the exact same. So this here is just not possible. Now let's do the next one here, B minus A. Okay, now I'm going to cheat a little bit with using technology, and I went on and copied them from the first time I wrote these down. So we get this here. So matrix B is our -4, -1, -3, -7. and we're subtracting from it matrix A, which is our 16, 2, negative 9, 8. Now, we already know that the dimensions for matrix A and B are the exact same. So we can go on and subtract, and we would subtract the corresponding elements. So our corresponding elements, so negative 4 minus 16. And negative 4 minus 16 would be negative 20. Top. These are the same elements. Then our next one would be negative 1 minus 2. And negative 1 minus 2 would be negative 3. Then our next one would be negative 3 in the first matrices, so negative 3 minus negative 9. Well, the negative and negative would give us a positive. And negative 3 plus 9 would be 6. And lastly, we have negative 7 minus 8. And negative 7 minus 8 would be negative 15. And yes, if you wanted to, you could have plugged this all into the calculator and done it that way and set up matrix A, B, and C and typed in A minus B or B minus A here, and it would give you the answer. And that's all we have to do for this here. So let's do some more here. They already have these written out for us, so that's a little bit nicer. So again, we're going to match up like elements. Well, before we can even start matching up like elements, we need to make sure they have the same dimensions, because if they don't, then we can't add or subtract. So 1A, so this here is a 2 by 2. Then we have a 2 by 2. So they do have the same dimensions, so we can subtract, because again, it's subtraction. We can subtract like elements. Their corresponding spots. We are going to subtract them. We're going to subtract those values from each other. And so when we do this here, well, the first one would be negative 3 minus negative 4. And we could type that in a calculator, go negative 3 minus negative 4, and hit enter. And if we do that, it'll tell us that it is 1. Because negative 3 minus negative 4 is the same as negative 3 plus 4, which would give us 1. Our next one would be 4 minus 12. And 4 minus 12 would be 8. Our next one would be negative 9 minus 8, which would be negative 1. And the last one would be negative 5 minus negative 7. Well, the negative and negative would give us a positive. So negative 5 plus 7, which is 2. Now, I probably should have gone on and written this out. I went on and just typed it out kind of after the fact of what we were doing. So when we subtract these, negative 3 minus negative 4. Well, the negative and negative became our positive, and negative 3 plus 4 would give us 1. 4 minus 12. 4 minus 12, again, I'm glad I wrote this out because it would be negative 8, not positive 8. 4 minus 12 would give us negative 8. Negative 9 minus 8 would give us negative, not 1, but negative 17. And negative 5 minus 7, well, negative and negative would give us a positive, and negative 5 plus 7 would be 2. So I'm glad I wrote that out because, again, I had those two numbers off. So it's easy to make these little mistakes when we're not paying attention or trying to skip steps. So if it's helpful, write it out. Or, again, like I said, you can type this into the calculator because the calculator will do it. Now let's look at this next one here. So we have a 2 by 3 and a 2 by 3. And because the dimensions are the exact same, we can combine like terms. So when we're combining our like terms, so we'd have negative 9 plus negative 4 in our first one. Then we'd have 8 plus negative 3. And we'd have 3 plus 6. So on the bottom, we'd have negative 2 plus our negative 9. We'd have 4 plus our negative 5. And then we have negative 7 plus 18. And that's what we're going to be doing in each one of these here, because each one, negative 9 and negative 4 correspond. 8 and negative 3 correspond on top. 3 and 6 correspond, and we're adding them together. And if we do this here, well, negative 4, or negative 9 plus negative 4 would be negative 13. Our 8 plus negative 3 would be 5. And 3 plus 6 would be 9. Now on bottom, we'd have negative 2 minus plus negative 9. Negative 2 plus negative 9, or negative 2 minus 9, which would be negative 11. We'd have 4 plus negative 5, which would be negative 1. And negative 7 plus 18 would be 11. So our matrice that we would get from adding these two together would be this one here. And that's all we have to do for this here. And we can move on to the next thing. Because so addition and subtraction, that's all it is. And as long as the dimensions are the exact same, we can add and subtract. But if the dimensions are not the exact same, we're not going to be able to add or subtract them. Now the other thing we have is scalars. Now a scalar is we're just taking whatever the number is, the scalar, and multiplying it by everything inside the matrix. Every number or every element in the matrix. And that's it. That's all we have to do for this here. So if I want to scale this matrix or have a scalar of 5, we're going to multiply everything inside this matrix by a factor of 5. So when we look at this matrix here, well, I'm going to take all these numbers inside and multiply them by 5. So we're going to have 5 times our negative 12. We'd have 5 times 8. And we'd have 5 times 6 on top. And then on bottom, we'd have 5 times negative 16. And we'd have 5 times 4. And lastly, we'd have 5 times 19. We're going to multiply each one of these by 5. We multiply everything in the matrix by 5 when we scale it by a factor of 5. And so lastly, we just need to simplify these here. So 5 times negative 12 would be negative 60. 5 times 8 would be 40. And 5 times 6 would be 30. Now 5 times negative 16 is going to be negative. 5 times 6 is 0, carry the 3, so it'd be 80. 5 times 4 would be 20. And lastly, 5 times 90, or 19, would be 95. And that's it. We just multiplied everything by 5. Now, it is possible to do these in a graphing calculator. You could type this matrix in, negative 12, 8, 6, negative 16, 4, 19 in, and do 5 times it, and it would give you the answer. So we can type these into the calculator also. And that's it. That's all we have to do for this here. That's all we have to do for scalars. Now, it doesn't matter if the scalar is negative, because here we have negative 4. We would do the exact same thing. We're going to multiply everything inside the matrix by its scalar. And this one here is negative 4. So we're going to multiply each number by negative 4. So we'd have negative 4 times 8. Then we'd have negative 4 times 0. Then we'd have negative 4 times 3. Then we'd have negative 4 times negative 2. And then on the next row, we'd have negative 4 times negative 1. Then we'd have negative 4 times negative 4. And then we would have negative 4 times negative 2. And lastly, we're going to have negative 4 times 9. There we go. Now I lined it up a little bit, so it probably looked like it just shifted, but I went on and lined them back up, so we kind of have it looking similar. And now all we need to do is multiply them together. Well, negative 4 times 8 would be negative 32. Negative 4 times 0 would be 0. Negative 4 times 3 would be negative 12. And negative 4 times negative 2 would be positive 8. And that's all we have for the first row. Now the second row would be negative 4 times negative 1, which would be 4. Well, negative 4 times negative 4, and negative make positive, and we would have 16. And then negative 4 times negative 2 would give us positive 8. And negative 4 times 9 would be negative 36. And that's it. That's all we have to do for this here. And this here is our answer, and we're done. And that's really it for scalars. And scalar is just multiplying by a number. Now we do have some properties with matrices. The commutative property of addition. A plus B is going to be the same as B plus A. It doesn't matter the order in which we add two matrices together, we will get the same thing. The associative property of addition, A plus B plus C is equal to A plus B plus C. The order in which we add matrices together doesn't matter. And we can kind of distribute a scalar from left or right. And that's it. Now we can also do these here, these multi-step operations. We can use scalars and addition, subtraction together. We can do them both at the same time. Well, not at the same time, we'll do one at a time, but we can use them together. So we'll look at this one here. Now the first thing we're going to do is, well, so we have negative 4b. So I'm going to cheat a little bit. And when I say cheat a little bit, I mean I'm just going to copy them. I'm going to take pictures of them so I don't have to rewrite these out. And what we're doing is negative 4 times our matrix B minus 3 times our matrix A. And now because they're both 2 by 2s, they're both the same dimensions, we can add and subtract. Scalars, it doesn't matter about dimensions, but again, we're adding and subtracting them together, so they still have to be the same dimensions. Now the first thing we can do is we can multiply by their scalars first before we add or subtract. And when I multiply by their scalars, well, we're just multiplying everything inside matrix B by negative 4. So we'd have negative 4 times negative 4. And then we'd have negative 4 times negative 8. And then on bottom we'd have negative 4 times 2. And then we'd have negative 4 times negative 3. And that would be our first matrix. And now the second matrix, we can multiply everything by negative 3. And there's nothing wrong with that. It would be negative 3 times negative 9. And then we'd have negative 3 times 12. Then on the bottom, we'd have negative 3 times 2. And then we'd have negative 3 times negative 6. And that would be our matrix here. Now, wait a minute. What happened to the negative? Because we were going to be subtracting. Well, I took the negative and did what? I applied it to everything inside this matrix here, yes? So since I did that, we will add them together. Once we finish simplifying the scalar, we are going to add like terms. Now, if you're wondering if I just multiplied by 3, yes, it would just stay subtraction. But because we pulled the negative in with the 3, it changed it from subtraction to addition. Now let's go on and simplify this here. Well, negative 4 times 4 would be 16. Negative 4 times negative 8 would be positive 32. Negative 4 times 2 would be negative 8. And negative 4 times negative 3 would be 12. So we have that there. Plus. Let's do the other matrix. Well, negative 3 times negative 9 would be 27. Negative 3 times 12 would be negative 36. Negative 3 times 2 would be negative 6. And negative 3 times 6 would be 12. So we multiplied. So we multiplied by our scalar. Now the last thing we need to do is just add. We need to add the like terms. So our like terms, well, would be 16 plus its corresponding term would be 27. 32 plus negative 36. Then we'd have negative 8 plus negative 6. And lastly, we're going to have 12 plus 12. And if we add these together and finish simplifying, well, 16 plus 27 would be 43. 32 plus negative 36 would be negative 4. Negative 8 plus negative 6 would be negative 14. And 12 plus 12 would be 24. And that's all we have to do for this here. And if you're wondering, yes, you could have typed this into a calculator and started off and typed it in for A and B and then just plugged that into the calculator, negative B, 4B minus 3A, and hit enter, and it would have given you your answer. It would have told you it was this here, 43, negative 4, negative 14, 24. And that's it. That's all we would have to have done. And the same thing would be true for this here. And I have a feeling at this point y'all have got a good handle on this because we have done this before. So if you wanted to, you can go on and give this a try and get your answer. All right, guys, so if you went on and calculated that out, you would get this matrix here, negative 107, negative 9, 12, negative 32, negative 10, and 105. And that's what you would get. And that's all we're going to do here for today. So your assignment for this here is on page 196, problems 1 through 10, all.